Hey everyone, this is Diego, the CEO of Cardiographic Medical Solution, and also part of the software team here at the company, in charge of developing both the application and the algorithms behind our product. I want to start off by discussing the problem that we're trying to solve here at the company, and why it is of big importance in today's society. So right now, in order to get any sort of diagnosis or feedback regarding your own cardiovascular health, you have to first book an appointment with your family doctor, where he or she will suggest to wear a Holter monitor. This is a little device that will track and view your heart from different angles. After that, you have to wait for the results to be analyzed by a cardiologist before they're sent back to you. This entire process is pretty lengthy, as it could extend anywhere between 3 to 5 weeks, and would be repeated back from square one if any or more symptoms showed up. It could be a much more efficient system if more people were to do self-monitoring with the use of wearable devices, and thus helping reduce the amount of waiting time between experiencing your first symptom and getting your results. This is where KMS sees the big problem and wants to step in and innovate by bringing in a new portable EKG monitor to the market that will hopefully lower down the number of deaths globally by catching early signs of cardiovascular diseases. Our new product, called Compression, will have the same portability as a smartwatch, but with an accuracy that resembles that of a Holter monitor for a preliminary diagnosis. We, as a company, are committed to monitoring the heart health of the world and make it as hassle-free and efficient as possible.
Hi everyone, my name is Matthew. I'm the Chief Technology Officer here at Cardiograph Medical Solutions. When looking at the ways we can innovate on current solutions, we saw the need for ease of use and comfortability. This led us to ask, what if heart health could be monitored and analyzed by simply wearing a shirt? Our product does just that, providing an all-in-one heart monitoring solution built into a compression shirt. The shirt streamlines and integrates all sensors and connections within the fabric. So whether lifting weights in the gym, going out for a run, or simply sitting at home, your heart health can easily be monitored. The EKG system in the shirt has electrodes that view the heart from 4 different angles. These electrodes are complemented with a pulse oximeter to track blood oxygen levels. Through connection to a mobile application, various ways to interpret the data are available. Within the application, one can view live tracking of heart rate, blood oxygen, and EKG signals. A timeline page provides summaries of stats for the day and a log of recordings. Making a recording can easily be started at any time from within the application. After recordings are completed, the application uses machine learning to perform heart rhythm analysis and provide information about any abnormal rhythm events. Reports can be generated summarizing an abnormal event to share with your doctor. Our solution allows for comfortable cardiac monitoring and analysis by simply wearing a shirt.
Hi, my name is Stefan and I'm part of the hardware team here at KMS. Officially, I am the CCO of the company and have been working on implementing hardware designs since January of 2021. Up to now, we've had multiple designs for detecting a one-lead bipolar EKG measurement. Up to date, we've had 3 circuit models. The first 2 circuit iterations did not provide usable output. However, after running many simulations and integration tests, our third version was able to record a decently clean-looking one-lead EKG measurement. The signal is displayed on the oscilloscope and the peak complexes can clearly be identified. Our design so far looks like the following block diagram presented in the dashed circles above the circuit model. 2 inputs come from the body and are fed into an instrumentation amplifier. An instrumentation amp is used due to its ability to maintain high input impedances into the difference amplifier. This instrumentation amp is fed into a bandpass filter to maintain the signal between 0.1 and 500 Hz as per the IEEE EKG amplifier standards. Then, the signal is passed to a voltage shifter to scale the signal accordingly between 0 and 5 volts. An Arduino Nano ADC then picks up the scaled voltage and sends it via the HM18 Bluetooth module to the user's cellular device. The electrodes currently being used are the Canadian Clinical Standard single-use electrodes provided by 3M. These electrodes are very sticky and provide reliable contact with the skin. Unfortunately, these are not the most sustainable options, but provide the best contact and signal for our proof of concept design. In contrast to this, each electronic component purchased was recycled and had previously been used in another circuit. This was done in an effort to keep our product more sustainable for the environment. For a finalized prototype design, we would like to include a stacked PCB capable of measuring 3 bipolar and 1 unipolar leads, all enclosed in a device just smaller than the size of your hand.
Hi, my name is Jamel, and I am the CFO at Cardiographic Medical Solutions. I work as a part of the hardware and system design team for our product, Compression. Let's take a look at the appearance proof of concept and design features it has to offer. Here is a live look at our test subject wearing Compression's proof of concept. As you can see here, the KMS device composed of PCBs, an Arduino, and a Bluetooth module is able to slot into the side of the compression shirt and attach directly to the sewed-on connection port using connectivity pins. The KMS device will stay put through the usage of a push-button spring clip and will never fall out whilst exercising. Being able to attach and remove this device will significantly aid in the shirt's ability to be washed. Taking a look at the inside of Compression, we can see 3 sewed-on electrodes, 1 right arm, 1 left arm, and 1 right leg. For this proof of concept, we will only be reading from a single lead connection to the shirt, with the inclusion of the right leg drive.
Big part of our product, Compression, relies on the interaction between our application and our detection algorithms that help provide a clear preliminary diagnosis for the user. We have developed CardioCare, a flatter, cross-platform application for both iOS and Android devices using Dart. And for our proof of concept, we have a single UI screen where the user is able to connect to our hardware via Bluetooth using just 2 buttons, and view their heart signals in real time after some signal processing. Later in our development pipeline, we will be implementing different screens, an arrhythmia prediction algorithm, heart rate and heart rate variability estimates, and the ability to store and export EKG data in a universal format that can be used by any medical professional.
Another important aspect of the application is arrhythmia detection. Arrhythmia detection will be present within the application using an open source neural network model. This model is being trained and validated using a dataset of 2.3 million short duration EKG records. We will deploy this model to detect 6 types of arrhythmia. Since the model is being trained to detect arrhythmia using 12 leads, and the compression shirt will only provide 4 leads, we will zero out the missing leads in the input. We have run tests to validate how this impacts performance on the original testing dataset used in our source. The precision score saw a decrease of 5.3% with the missing leads. The results are reassuring since they let us know the model hasn't had a dramatic increase in the number of false positives. Moving forward, we will deploy the model to the application and run more tests to see how it behaves with real data from our device.
By now, you've seen a sneak peek of what our product will look like and what features it will have, as well as what our company is all about and what we're working towards. On behalf of everyone here at the company, thank you for watching this video.